Welcome to our project, Loan Eligibility Prediction, using Gradient Boosting Classifier. In this tutorial, we'll use a powerful machine learning model to predict whether someone qualifies for a loan. We'll be working step by step in Google Colab, from loading and cleaning the data to building, training, and testing the model. Let's get started. Mount Google Drive. Connects Google Drive to Colab for file access. Install FancyImpute in Colab. Installs the FancyImpute library for advanced missing data imputation. Import libraries for ML pipeline in Colab. Loads essential libraries for data preprocessing, visualization, modeling, evaluation, and handling imbalanced datasets. Load the dataset and fix compatibility issues. Resolves deprecated module references in Scikit-learn and loads the loan eligibility dataset from Google Drive for analysis. Numerical and categorical features. Generates statistical summaries for numerical columns and value counts for each categorical column to understand data distribution. Drop unnecessary columns and check missing values. Removes identifier columns and checks for missing values to prepare the dataset for further preprocessing. Handle missing and inconsistent values. Fills missing values using median mode strategies and converts specific columns to numeric types to ensure data consistency. Summary statistics for current loan amount. Displays key statistical metrics count, mean, STD, min, max, quartiles for the current loan amount feature. Visualize the distribution of current loan amount. Plots a histogram with KG to explore the distribution and frequency of loan amounts in the dataset. Box plot to detect outliers in current loan amount. Visualizes outliers and spread of the current loan amount feature using a box plot. Calculate IQR and outlier boundaries. Computes the inner quartile range and determines lower and upper bounds to identify potential outliers in the current loan amount data. Identify outliers in current loan amount. Extracts and displays the last few outlier values in the current loan amount column based on the IQR method. Handle outliers and visualize cleaned loan amount. Replaces extreme outlier values with NaN. Imputes them using median, and then visualizes the updated distribution of current loan amount. Summary statistics for credit score. Displays key statistical metrics for the credit score feature, including count, mean, standard deviation, min, max, and quartiles. Visualize the distribution of credit score. Plots a histogram with KG to show the frequency distribution of credit scores in the dataset. Distribution plot of credit score. Uses a Seaborn dist plot to visualize the distribution and density of the credit score feature. Cap outliers in credit score. Limits extreme values in the credit score column using 5th and 95th percentiles and visualizes the capped distribution with a box plot. Unique values in years in current job. Displays all distinct categories or values present in the years in current job column. Encode and visualize years in current job. Converts job tenure categories to numeric values and plots their frequency distribution as a histogram. Summary statistics for annual income. Shows key statistical measures like count, mean, standard deviation, min, max, and quartiles for the annual income feature. Visualize distribution and outliers of annual income. Displays a distribution plot and box plot side by side to analyze the spread and outliers in the annual income feature. Annual income quantile analysis. Calculates specific percentiles to understand the distribution and identify thresholds for the annual income feature. Cap annual income at 95th percentile and visualize. Limits annual income values to the 95th percentile to reduce outliers and displays the updated distribution with a histogram. Summary statistics for monthly debt provides key statistical metrics like count, mean, standard deviation, min, max, and quartiles for the monthly debt feature. Monthly debt quantile analysis calculates detailed percentiles to understand the distribution and identify thresholds for the monthly debt feature. Box plot of monthly debt visualizes the distribution and detects outliers in the monthly debt feature using a box plot. Cap monthly debt at 99th percentile and visualize, limits extreme monthly debt values to the 99th percentile, and displays the updated distribution with a histogram. Impute missing monthly debt and summarize years of credit history. Fills missing values in monthly debt with the median and shows summary statistics for years of credit history. Distribution of years of credit history. Plots a histogram with KD to visualize the frequency and distribution of years of credit history in the dataset. Summary statistics for number of open accounts provides count, mean, standard deviation, min, max, and quartiles for the number of open accounts feature. Distribution of number of open accounts visualizes the frequency distribution of the number of open accounts feature using a histogram with KD. Quantile analysis of number of open accounts calculates key percentiles, including extreme values, to understand the distribution of the number of open accounts feature. Cap number of open accounts and visualize distribution. Limits number of open accounts values to a maximum of 36 to handle outliers and visualizes the updated distribution. Distribution of years of credit history. Plots a histogram with KD to examine the distribution and frequency of years of credit history in the dataset. Summary statistics for years of credit history. Displays descriptive statistics, count, mean, STD, min, max, and quartiles for the years of credit history feature. Summary statistics for maximum open credit provides key statistical measures such as count, mean, standard deviation, min, max, and quartiles for the maximum open credit feature. Check missing values in maximum open credit returns the total number of missing values in the maximum open credit column. Quantile analysis of maximum open credit calculates selected percentiles to understand the distribution and detect outlier thresholds in the maximum open credit feature. Box plot of maximum open credit uses a colorful box plot to visualize the spread and detect outliers in the maximum open credit feature. Handle outliers in maximum open credit and visualize. Detects outliers using the IQR method, replaces them with NaN, imputes with the median, and visualizes the cleaned data using a box plot. Distribution of maximum open credit displays the frequency and density of the maximum open credit feature after handling outliers using a histogram with KD. Distribution of bankruptcies plots the frequency and density of the bankruptcies feature using a histogram with KD to explore its distribution. Cap bankruptcies at 99th percentile and describe credit problems. Limits extreme values in bankruptcies using the 99th percentile and displays summary statistics for number of credit problems. Distribution of current credit balance visualizes the distribution and density of the current credit balance feature using a histogram with KD. Quantile analysis of current credit balance calculates upper percentiles of the current credit balance feature to assess distribution and identify potential outlier thresholds. Cap and transform current credit balance for visualization. Caps extreme values in current credit balance, applies square root transformation to reduce skewness, and plots the clean distribution with KD. Visualize distributions of all numerical features. Automatically generates histograms with KD for all numerical columns in the dataset to explore their individual distributions. Explore categorical features. Iterates through all categorical columns, displaying value counts and unique values to understand category distribution and detect inconsistencies. Frequency of home ownership categories. Displays the count of each category within the home ownership feature to understand its distribution. Clean and visualize home ownership distribution. Replaces inconsistent labels in home ownership and displays a pie chart showing the proportion of each ownership type in the dataset. Standardize purpose categories. fixes inconsistent casing in the purpose column by replacing lowercase other with other and lists all unique purpose categories. Distribution of loan purposes displays the frequency of each loan purpose using a count plot to analyze category distribution in the purpose feature. Visualize distributions of key categorical features. Creates count plots for selected categorical features, loan status, term, home ownership, and purpose to analyze their frequency and class balance. Analyze loan status by credit score and annual income. Uses box plots to compare the distribution of credit score and annual income across different loan status categories, helping reveal patterns or disparities. Correlation matrix of loan factors. Computes and visualizes the correlation between numerical features related to loans using a heat map to identify strong relationships and multicollinearity. Annual income versus current credit balance by loan status. Creates a scatter plot to visualize the relationship between annual income and current credit balance, with points colored by loan status to reveal patterns or group differences. Encode categorical features and scale numeric data. Applies label encoding to categorical variables, standardizes numerical features, and separates the dataset into features X and target Y for model training. Split dataset into training and testing sets. Divides the data into 80% training and 20% testing subsets to prepare for model training and evaluation. Define multiple classification models. Initializes a dictionary of various machine learning classifiers for loan status prediction, including logistic regression, ridge classifier, decision tree, gradient boosting, and random forest. Model evaluation function with metrics and visualizations. Defines a reusable function to train a classifier, then display its confusion matrix, classification report accuracy, and ROC curve in a comprehensive visual layout. Evaluate multiple models on test data. Iterates over predefined classifiers, trains each, and uses the evaluation function to display performance metrics and visualizations for comparison. Collect and summarize model evaluation metrics. Trains each model, computes accuracy and AUC, stores confusion matrices, and compiles a summary data frame for easy comparison of model performances. Compare ROC curves across all models. Trains each model, stores performance metrics, and plots ROC curves to visually compare model discrimination capabilities. Install Imbalanced Learn library. Installs the Imbalanced Learn package, which provides tools like SMOTE to handle imbalanced datasets during machine learning. Apply SMOTE to handle class imbalance. Uses SMOTE to balance the training dataset by generating synthetic samples for the minority class and displays the updated class distribution. Retrain and evaluate models on balanced data. Splits the SMOTE balanced dataset into training and testing sets, then retrains and evaluates all models to assess performance improvements after handling class imbalance. Evaluate and compare models after SMOTE. Trains all classifiers on the SMOTE balanced dataset, computes key metrics including accuracy and AUC, and plots ROC curves to compare model performance on the resampled test set. Summarize model performance after balancing. Creates a summary data frame showing each model's accuracy, AUC, and confusion matrix after training on the SMOTE balanced dataset for easy comparison and reporting. Select and save the best performing model. Trains all models, evaluates them based on AUC or accuracy, identifies the best performing model, saves it as bestmodel.joblib, and prints a summary table for comparison. Load and display the best model. Loads the saved best performing model from disk and displays its details for further use or inference. Load and preview unseen test data. Loads the new test dataset from the specified path and displays the first few rows to verify successful import and structure. Clean test data. Handle missing values and drop IDs. fills missing values in months since last delinquent, with the median and removes irrelevant columns for prediction. Pre-process test data and predict loan status. Encodes categorical variables, scales numeric features, separates features and target, and uses the saved best model to generate predictions on the test dataset. We successfully built loan eligibility prediction using Gradient Boosting Classifier. After cleaning and pre-processing the data, handling outliers and class imbalance with SMOTE, we trained multiple models. Gradient boosting delivered the best results with high accuracy and AUC, enabling fast and reliable loan approval predictions. For more exciting AI projects, stay with us, and don't forget to visit AIonlinecourse.com. That's all, today's video. Thank you for watching. If you liked this project, don't forget to hit the like button and subscribe for more tech tutorials.